Hello, this is a brief review of assigning priority groups for chiral centers, or chirality centers, some call, and then assigning RNS configurations. So it's not intended to cover the whole subject. And carbons that have 4 different things attached, as you see here, this one, are chiral. And so they have a non-superimposable mirror image. They have an enantiomer. You can refresh on all that from the book. You do have to use the wedges and the hash marks to show stereochemistry. And remember, this is only dealing with tetrahedral geometries. So anything around a double bond, trigonal planar, or a triple bond linear cannot be chiral. So the first job is to assign priority groups. With this molecule, we have priority groups 1 through 4 shown here. This is based on atomic number, so bromine is the highest atomic number at 1. Oxygen is next at 2. Carbon is next at 3, and hydrogen is the easy to find lowest priority at 4. You go atom by atom, coming out from the chiral center. So the atoms that are directly attached, oxygen, hydrogen, bromine, carbon, these are the orders of priority. With group 4 pointing away from you, as it says here, look at the orientation of groups 1, 2, and 3, and you'll see that they're counterclockwise. If it's counterclockwise, we call it the S configuration, as long as 4 is pointing away from you. If we switch any 2 groups, in fact, we should get the enantiomer, we should get the R configuration. But it's easy to check. I switched 2 of the groups in this lower structure. Which 2 did I switch? The OH and the bromine. So we already had the priority groups 1, 2, 3, 4. As we're looking at it with 4 pointing away from us, it's 1 to 2 to 3 clockwise. And yes, then it's the R configuration, clockwise. So what do you do if group 4 is pointing toward you and not away from you? That's pretty easy situation. You just go through everything the same way, and at the end you reverse it. So our priority groups are already assigned, 1, 2, 3, 4. As we're looking at it, it's going from 1 to 2 to 3 around in this circle. That suggests that it's the R configuration, but with 4 pointing toward us, we just reverse it and say it's S configuration, which in fact is what it would be if we were standing behind the screen looking at it from the opposite side. With that, and 4 would be pointing away from us. If you get good at this, you can do this in your head much more easily. But there's additional rules for assigning priority groups in more complex scenarios. This one here we see we have chirality center right there. Group 4 is easy to spot. Then you go atom by atom. Carbon, carbon, carbon. Those are all, that's a 3-way tie. So what do you have to do? You have to go outward, never backward, out to the next 3 atoms attached, excuse me. So attached to this carbon is a hydrogen, hydrogen, and another carbon. And we stop there. We don't keep going out. Hold on now. What's attached to this carbon, which is tied with this one and this one? Carbon here has a hydrogen attached, a carbon attached, and then what else? When you have a double bond like this and it's attached to another carbon, you say there's another imaginary carbon there. So in our atom counting, we say that that's a CCH. What's attached to this carbon, H, H, H. So our priority groups for this are 1, 4, 2, 3. And then as we're looking at it, it's 1 to 2 to 3 with 4 pointing away from us clockwise. That is the R configuration. Now, the one on the bottom, we have group 4, group 3. How do we decide between groups 1 and 2? And group 3 is easy to spot because it is a carbon, but you have hydrogen, hydrogen, hydrogen. As we saw above, that's going to be lower priority than any of these other two. So between 1 and 2, we have, which we don't know which one's which yet, attached to this carbon here above is a carbon, an oxygen, and then how do we do this? If it's a carbon double bonded to oxygen, we consider it an imaginary oxygen. And then here, so that's COO. Now, what about down here? Attached to this carbon here, O, 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 but we have an H, not a C. So here is our group 1, 4, 3, 2. As we're looking at it, it's 1 to 2 to 3 counterclockwise, S configuration. So that's pretty much most of it.